was going to ask
I'm Shivshankar Palit from India. Ma'am, thanks for the wonderful presentation. Ma'am, currently I am an undergraduate student and I'm interested in astrobiology, both in the fundamental part of it and also in the application part of it. So in the application part of it, it comes space biology or space physiology and space medicine. Ma'am, can you please tell me how can chemists contribute to this field of space medicine and physiology? And if nanobots could play a role in drug delivery in space?
Yeah, so I think nanobots could definitely play a role in drug delivery. So interesting, the studies we do on drug delivery in space are not for spaceflight. They're actually for the pharmaceutical companies on the Earth looking at drug delivery in patients on Earth because they're taking out the component of gravity to better figure out how those nanoparticles disperse. It actually just gives them more info. So what surprised me on orbit was that 80% of the life science research we do on orbit is not for space. It is not for space travel. It is for Earth to improve health down here. So, and that was your second question. What was your first question again?
Ma'am, how can chemists contribute to the research of space physiology and space medicine?
I'll tell you where we need you, and that's drug delivery, drug stability, pharmaceutical stability. I was part of a big meeting about a year and a half ago looking at how pharmaceuticals act under the space radiation environment. How do we preserve, how effective they are? How do we make sure we're not breaking a pharmaceutical component down into more toxic chemical substrate for patients? That is the first thing that comes to mind. Because it's huge, right? We're not going to have a Walgreens or a pharmaceutical, any sort of pharmacy on Mars or even on the moon. So pharmaceutical stability is probably one of the biggest areas. We had a lot of chemists come in from academia and outside industry to help us begin to ask the right questions that we need to look at for research.
And ma'am, if you could kindly elaborate on why is the research done in space? For pharmaceuticals related to people on Earth and not on Earth. As you said, most of the space research which chemists do are because of the pharmaceuticals related to the medicines required on Earth. Why is the research done in space?
Because a lot of the chemical compounds and structures that we look at, for example, different protein structures and compounds, in space, we see a lot of it looks at protein crystal growth formation. And so in space, those compounds grow in a better 3D fashion because we don't have gravity limiting things to the bottom of a cell culture plate. So compounds grow better 3D, which gives us better insight into a structure. So a lot of the compounds that I looked at, depending on what issue we were looking at, Parkinson's disease, Alzheimer's disease, looking at tau proteins, scientists get a better view of that substance in the microgravity environment because the growth is so much better and a much better ordered 3D structure. I hope that helps.
Yes, ma'am. Thank you, ma'am.